Hello everyone, this is my Sam. For my t-test analysis, my hypothesis was that there was very little statistical difference between 2016 and 2017 centers shuttle times. There weren't any outliers and no numbers were skewed in this data set. My F-stat, according to the F-stat, the data was equal. My hypothesis, well, there it is again. A t-test, assuming equal variance is what I chose to do since I figured it was equal. According to the t-stat, there is a significant difference between the centers from 2016 and centers from 2017 on shuttle times. Therefore, we have to reject the hypothesis. The effect size calculated effect size for the difference between the two groups has a Cohen negative 0.18. Correlation on my correlation analysis, the hypothesis, there is a statistical significance between weight and 40-yard dash times in 2013 quarterbacks. There wasn't any skewed data. Correlation on weight dash times gave me a R squared of 0.36 or R 0.36. According to the significance tables, this is statistically significant with the p value right there. We can confirm the hypothesis. I'll just leave this right here. Alright, my effect size according to Cohen. This would be a moderate effect size because it is between 0.3 and 0.5. There's my trend line with the 40 yard along with the weight that I use. Alright, regression. My regression analysis hypothesis, I predict that height, mass, and broad jump could predict flight time peak power, or peak power. The skewed synchretosis, there wasn't any data that was skewed there. The initial regression, height wasn't a factor. My second regression, mass and broad jump, could predict peak power with 83% accuracy. My regression equation right there, my y-intercept was peak time, or flight time peak power, which equaled out to be mass times 59.735 times broad jump distance times 940.628, and then you add the y-intercept, or not the y-intercept, but the 12,213.875. Alright, regression chart there with peak power with the trend line. Hypothesis for ANOVA, there's no statistically significant difference between linemen on bench press in years 2003, 2012, and 2016. The data was skewed slightly, but not a whole lot. The single factor, I used ANOVA single factor. The results show that there's a moderate statistical difference between years with a p-value of 0.31. On Bonferroni, there's no statistical difference between 2003 or 12 or 16 on bench press, and the effect size estimates for between 2003 and 2012 was 0.31, which is a moderate effect size estimate. Between 03 and 16, there's a 0.44, which is a moderate as well, and then between 12 and 16, there was a 0.13 effect size estimate, which is a small effect size estimate. So in the summary, in the t-test, 2017 centers were faster than 2016 centers on the shuttle. The correlation weight has an effect on 40-yard dash. Makes sense because typically, if you're heavier, you are going to move a little slower, so you could produce, and it produces a higher 40-yard dash time. On the regression, mass and broad jump can influence peak power. It makes sense because if you can produce more power On your broad jump, you can probably produce more peak power, giving you a higher number. On the ANOVA analysis between the years 2013, 2012, and 2016, bench press has varied about the same within each year. So not a lot has changed over a 13-year period. That is it. Thank you.